Welcome to our webinar today. It's called Pitfalls and Precautions of Using SolidWorks Without a Data Management Process. And really what we're going to talk about today is some of the issues you can run into with SolidWorks files when you're storing them and accessing them with multiple people and you don't really have any sort of data management process in place. Just to go over a little bit of an agenda, I'm going to talk about some of the typical problems that we're going to go through. After we talk about those, we're going to really dive deep into how SolidWorks pulls references and opens reference files. You guys are going to be probably pretty surprised about how this process is done. We're also going to talk about using SolidWorks Explorer to make a couple tasks a little bit easier. We're going to talk about some methods you can use to revision control when you don't have a data management tool. I'm going to talk about some of the things that you may run into when working in a collaborative environment with multiple engineers. And really quickly at the end, I'm going to show you just a few of the PDM tools that are out there. Just a couple of things in relation to what a PDM tool can do to help you guys. So just really quickly at the end, kind of wrap it all up, and then I've got some links and stuff at the end of this presentation. The presentation will be downloadable. We'll probably post that in the next week or so you can get this PowerPoint that I'm using, and you're going to be able to get a recorded version of everything that I'm saying as well. So hopefully you can spread that around to people that didn't get to see this presentation, make sure everybody knows what's going on. And so with that, let's go ahead and start. And the first thing I want to talk about is the typical problems that you're going to run into when you have SolidWorks but you don't have a data management tool. And probably something everybody has run into is that you've got missing and or incorrect reference files. So you open up the SolidWorks assembly, you open up a drawing, and it tells you that it can't find the file, or it needs you to browse for a file or something like that. That is a very common thing that happens when you're not necessarily managing your references as well as you could be. The other thing is if you rename a file and you open a SolidWorks assembly and the assembly can't find that file now because it's renamed. Very common. There is definitely an easy way to get around that I'm going to show you guys. Revision control is always an issue when dealing without a data management tool. So I've seen people do it a lot of different ways. Some work really well, some don't work at all. So I'm going to kind of give you my opinion on that and how it should be done. Just a few pointers on when you're collaborating with people, things that can go wrong, things that you can do to avoid that, and file overwriting and slow file opening kind of roll into that collaboration discussion that we're going to have. And so the first thing that I want to go into is how SolidWorks deals with file references. One of the most important things that I think you can understand is how SolidWorks searches for these things. So when you open an assembly, how does it find the parts that that assembly uses? Okay, the algorithm is fairly complex and it goes through 13 different steps. And one of the most shocking things to me when I started looking into this is that of the 13 steps, it does not look for the part in the location it was last saved to until the 12th step. That is the absolute last place that it looks for a file. So it looks in multiple places before it ever looks in the most obvious place, and that was just shocking to me. But what I have found is that if you understand this process and you work within this process, you can make yourself a whole lot more effective just by understanding the rules. So the first place that it's going to look for a file is actually, well, you know what, before I do that, let me just give you guys some background information. So we're going to go through an example here, and I'm going to be talking about a bunch of different file locations. So just to set that up, I'm going to say, pardon me, that we have an assembly called Assembly1, and that is stored on the S drive in the TT folder. And the S drive may be a map drive to a server network, it may be a USB drive, whatever it is. That's just the drive where my assembly is stored. I've also got a part that goes into that assembly, and that part was saved on my C drive in the XX folder. And that XX folder is a subfolder of the YY folder, which is a subfolder of the ZZ folder. So that's where my bracket.sldprt file is stored. I've also got two locations listed in my SolidWorks options. So for those of you who are unfamiliar with this, let me make sure that we can get into SolidWorks for a second, and I'll show you what these locations are that I'm talking about. So for those of you who are familiar, if you go into the SolidWorks options, you'll see something by the name of file locations, and in that file locations area you can set up a bunch of different paths. And these two paths, you've got the AABB folder on my D drive and the CC and DD folder on my F drive. Those are the paths that we're talking about here. So tools, options inside SolidWorks, and then as you bring up those options you'll see file locations, and under this drop down right here you're going to notice the second one is referenced documents. That's the location where this D drive and these F drive folders are. And that's just basically telling SolidWorks that it can go through and it can search those locations, and you'll see through my example here how that rolls in. So if we go on to step one, the absolute first place that SolidWorks looks for references is actually RAM. So when you open an assembly and the assembly begins looking for the parts that you need to build that assembly, the very first place that it looks for those files is in RAM. It's looking for files that are already open. Now, this can become an issue if you are using the same file name for files with different geometry. So in my example here, let's say that we have assembly 1, and that uses bracket.sldprt. Now that bracket is just a universal bracket component that has 3 mounting holes. Okay, so in a different assembly, let's call it assembly 2, I also use a bracket. Completely different geometry, but unfortunately we've called it the same file name, and that bracket only has 2 mounting holes. So what's going to happen here is if you have assembly 1 open, assembly 1 is in RAM, and all the files that assembly 1 needs to be built are in RAM, unless they're in lightweight, which is a different story altogether. But because the bracket with 3 mounting holes is open in RAM, if you then go and open assembly 2, even though it's the wrong geometry, it's going to use the bracket with 3 mounting holes in assembly 2. That's going to throw everything off in your assembly. Your mates are going to break, everything's going to go wrong because it's opening the wrong file. SolidWorks doesn't necessarily care that the geometry is different. All it's looking for is that file name, and because that file name is in RAM, it opens it immediately. Not something that happens very often, but definitely something that I've seen in my day-to-day before. So the second place that SolidWorks is going to actually go and look for those references if it does not find them in RAM is those file locations that I just showed you in SolidWorks. So you can see under your SolidWorks options, if you go to file locations and reference documents, I've got D/AA/BB, F/CC/DD. Okay? So what it does is it goes to the first location in this list. It's going to go and it's going to look for bracket.sldprt in the D:AA/BB folder. Now, if it doesn't find it there, it's going to move on to step 3. And what I should point out is that this only happens, step 2 and all the steps that relate to step 2, only happens if you have a specific option turned on. So in your SolidWorks options, under the external references area, you're going to see an option for search file locations for external references. If you have a check mark there, then it's going to go through these. If it doesn't, it's basically going to skip steps 2 through 7, and it's going to go right to step 8. So keep that in mind as we're going through this presentation. Now step 3, if it was not found in step 2, is going to be the location from step 2, but we're going to append the very last folder that the part was in onto that location. So remember, our part was stored on the C drive in the ZZYYXX folder. And so because in step 2 we were searching DAABB, it's going to take XX because that's the last folder of where the part was saved, and it's going to search there. So it's going to search in DAABBXX. Now what's interesting about this is that that folder may not even exist. Okay, that may be a completely fictitious folder, but even if it doesn't exist, SolidWorks is going to go out there and it's going to try to find it. Okay, so even if the folder's not there, we're still wasting time going and trying to look in this non-existent folder. So now if it doesn't find that file in step 3, the next thing it's going to do is append one more folder from the original path to that path from step 2. So in our case, this next folder is going to be DAABBYYXX. Again, something that may not even exist, but this is simply the algorithm SolidWorks is using to find these files. So I think you guys can probably understand what's going to happen for the next couple of steps. Basically, when you go into step 5, it's going to keep repeating step 4 until the original path has been appended. So in our case, the original path was CZZYYXX. So in our case, step 5 is going to be the last step. It doesn't have to go up the tree anymore. And it's going to go search in DAABBZZYYXX. I know this might sound a little confusing as I'm throwing all these numbers out here, and that's why I'm going to put this presentation on the web afterwards, but essentially it's just trying to climb up the tree and append these folders, just in case you may have moved it from a server location to a local location or something like that. Okay, so once the tool has exhausted those locations, what it does is it sticks with the original location in step 2. So remember, step 2 was DAABB. It's going to go back to that, and it's going to start recursively searching through it, which means it's going to remove BB. So it's going to search in D:AA. And the recursiveness of this means that it's going to start just stepping back up through that folder structure one more time until you have the path completely removed from the file locations list. So we get DAA, then we add an XX to it, then we add a YY, then we add a ZZ, and then AA goes away completely, and you're going to be searching in DXX, then DYYXX, DZZYYXX. Okay, so that's the recursiveness in this search routine. Step 7 is actually going to be the exact same pattern. We're just going to go to the next location listed in those file locations in the SolidWorks options. And since that was FCCDD, it's going to start there. And you can see, as I have listed here, it's going to recursively search again through that whole pattern of folders. And like I said before, these may be folders that don't even exist. So it's obviously not going to find anything there. So if we move on to step 8, what it does is it searches the path of the active document. So the active document is the file we just opened, the assembly we just opened. So we opened that from the S drive out of the TT folder. So it's going to look for bracket.solidpart in the S drive's TT folder. If it doesn't find it there, it's going to go back through this whole recursive searching method, appending the folder locations until it just gets to the S drive with the original folder location. Now, something that's interesting here, had I opened the assembly from the C drive, the very last path right here would be CZZYYXX, which is where the bracket file is, and it would have found the bracket file right here. But because I opened the assembly from a different drive, the S drive, we've got that S number in front of here, and it's not going to find it at this point. Now, the other thing to note is that step 8 is actually where it would start. if you had that option turned off to search for the external references in file locations. So it would have skipped right here to step 8. The next step is that it actually searches the path where you last opened a document from. Now, in 99% of the cases, step 8 and step 9 are exactly the same because the last document you opened is the active document that you have on the screen. The only time you have a situation where the last document opened and the active document are not the same is if you opened a document through File Open and then you went into Windows Explorer and dragged a file into it. So for instance, you opened an assembly and then you drug a file into that assembly from Windows Explorer. In that case, step 8 and step 9 are going to be the same. Are going to be different, sorry. In our case, step 8 and step 9 are exactly the same. So again, you can see it's searching the S drive for those paths. Step 10 now is that it's actually going to search the path where the software last found a reference document. And so if bracket.sldprt was the very first document in this assembly that it was looking for, step 10 is not going to have a path because it hasn't found a reference document yet. But if bracket was the second part or some part thereafter, it will have actually found a number of references before that, and it will look through those locations to find bracket.sldprt, which makes sense, assuming that you store some of your files in the same location. Step 11 is that it actually takes the path, so it would take that ZZYYXX path without a drive designation. So if you guys are storing through UNC paths, which is fairly uncommon but does happen sometimes, this is where it would start to search for UNC stuff because you don't have a drive letter associated with it anymore. And then finally, at the very end of this whole thing is step 12. And step 12 goes and it searches the explicit location where the file was last saved. So in our case, it's on the C drive, ZZYYXX folder. And again, it's a little shocking to me that this is the last step that happens, but for whatever reason, that's how this algorithm works. And now the 13th step, and I'm sure everybody who's attending this webinar has seen it before, is that little pop-up box that says, hey, I can't find the file, I need you to find it yourself. Okay, and we hit browse and we look for the file and it updates. That's when it's exhausted all its resources and it just needs you to figure it out for it. Okay, so how does this affect us? Well, if you look through this example I've done, I counted all the locations up and it is searching in 39 locations before it actually finds that bracket part. Now 39 locations may not seem like a lot, but if you have very, very deep folder structures, if you have a lot of subfolders, that number is going to skyrocket exponentially. And the thing about this is that if those locations are also server locations, it's going to search those server locations much slower than it can search local locations. So if it's really searching, 39, maybe it's searching 100 locations, you are going to see a definite speed decrease when trying to open these assemblies, especially if it's running through this algorithm for every single file in a 100-part assembly. You guys can probably see how the time would add up there, so I'm not going to dive into it too much. Okay. Now, in our case, SolidWorks would have eventually found the file, right? In that 12th step, it would have found that file. But if we had moved that file, or we had renamed that file and it couldn't find it, it's going to prompt us. So it's going to go through all that searching method, and then it's going to ask us to find it. And if we weren't the ones who moved it, or we don't know where it is anymore, and we can't find it, the SolidWorks assembly is going to suppress it, and we're not going to be able to use it until we can figure out where that file is. So you may go through all that hassle just to end up with a suppressed part in the end. A couple things you guys should take away from this, okay? The first is to not use duplicate file names if you can avoid it. I'm sure this sounds like basic standard logic, but you would be absolutely surprised at how many times I see duplicate file names. And I'm not only talking about duplicate file names on your computer, I'm talking about duplicate file names anywhere, be it on your computer, be it two engineers using the same file names. You know, it could be people in different geographic locations using the same file names. You could be getting files from your vendor that have the same file names as what you have. If you have a part numbering system in place, you should definitely be using that part numbering system. And if you don't have a part numbering system in place, it really makes a lot of sense to go and figure out something so that you don't run into this issue, because it can cause a lot of headaches. Okay, the second thing I want you to take away from this is to use consistent file locations across your organization. You know, if I've got like a test folder on my desktop and my colleague Bob has a sample folder somewhere buried in his C drive and we're trying to share things back and forth, you can imagine the reference disaster that that would cause. You know, he's going to have a lot of things referencing his drive that I can't see, so when I open them, it can't find them. He's going to open stuff that's referencing my drive that he can't see, so he's not going to be able to open it. So if you use consistent file locations, and this doesn't necessarily have to be on the server, right? If you don't have a server, that's fine. But if you're going to share files, come up with a structure that everybody has on their computer. Maybe put a working folder on the C drive that everybody uses, so that when you're looking for files, it's looking in the C working folder. Now, you got a couple different options out there, but the more consistency you have, the less errors you're going to run into. Okay, the third thing here is to avoid saving files locally that others need access to. So if you are sharing data across your organization, it's a really good idea to make sure those files are saved to the server. Sure, you're going to take a little bit of a performance hit because you have to save across the network, but ultimately, if you're saving files to the network and the references are getting written to network locations that everyone can see, you're not going to open files and see it down in the lower left-hand corner searching for something on someone else's drive. It's just a little consistency thing that you can maintain. If you're using mapped drives, like in my example, the S drive was a mapped drive, you need to make sure that everyone maps to the same drive letter. You wouldn't believe how many times I'll go out to organizations and I'll see somebody has it mapped to the T drive and somebody has it mapped to the G drive, and these drives don't commingle with each other in terms of the SolidWorks reference searching, so you end up with these referencing issues. So again, you can kind of see this is all about consistency. But the last thing I'll say is that now that you know this method that SolidWorks uses, you can really strategically use it to your advantage. So what I like to tell people to do, and a common example of this is toolbox components. You know, people may have their toolbox files stored on the network. So if you go to the SolidWorks options and you add the very top level folder of where your toolbox files are stored on the network in everybody's computer, one of the first locations that gets searched for references will be that toolbox folder. And as it does its recursive searching, it's pretty much guaranteed it's going to find the right folder that it's looking for. So instead of pulling toolbox files off local drives and having a whole big mess of things, you've got everybody pointed to that drive and you're strategically using this to your advantage. If you want a little bit more tips and tricks on that, you can feel free to contact me later. I've got my contact info at the end of this presentation that you guys can see. But that's something that I've found really works quite well, especially if you move servers or you move folder locations or stuff like that. This kind of thing can really, really help you. Alright, so next thing I want to talk about is moving and renaming SolidWorks files. This is something that everybody does. You know, you got files, you have to rename them, you have to move them. It's just a fact of life. The problem is this is probably one of the biggest killers when it comes to using references improperly. Okay, so the problem here is that Windows has absolutely no idea that these SolidWorks files are connected together. When they're open inside SolidWorks, SolidWorks obviously understands that, But as soon as you close SolidWorks and you're just browsing your C drive or browsing the server looking for files, Windows Explorer has no idea that there's references here. The problem with that is that when you move files or you rename files, it can't rewrite those references. So when you go to open the assembly or the drawing again and files have been renamed, well, it can't find those files because it didn't know they were renamed in the first place. Now, I've got this written up here. Does that mean you cannot move or rename SolidWorks files? No, it definitely does not mean that. It just means that you have to understand the proper method for doing this so that your references don't get broken. So what is the proper method for doing so? Well, I like to use SolidWorks Explorer. I'm going to talk about how you can use SolidWorks to do this, but I find that doing this inside of SolidWorks Explorer is significantly easier and significantly faster than any other tool out there. So we've got SolidWorks Explorer up here, a little screenshot of it. SolidWorks Explorer comes with every installation of SolidWorks. Whether you have basic SolidWorks or premium SolidWorks, everybody gets SolidWorks Explorer. It has kind of a similar look and feel to Windows Explorer, but the one difference in SolidWorks Explorer is that it actually understands SolidWorks references. Now, it's not the magic button, okay? There's a caveat that I'm going to talk about at the end of this that you need to be aware of, but it does a very good job so long as you are aware of its limitations. And I'm going to open SolidWorks Explorer real fast just to give you an idea of what it does. So let me go over here and bring up my Start menu. If you go to All Programs, SolidWorks 2010, and I've got SolidWorks Explorer right here. And we can see that when SolidWorks Explorer loads, it's basically just a file browsing dialog. Okay, so I can expand my desktop, and I happen to have some example files on my desktop. In that example folder, you know, I've got a tree stand, a ball pump, and a bike pump. If I browse into that tree stand folder, I've got a bunch of files. The cool thing about SolidWorks Explorer is that if I browse into that on the right-hand side, I can see a preview of those files. So it'll give me a little bitmap preview of all the different files as I can scroll through them here inside SolidWorks Explorer. It's also going to allow you to select files. So I've got this assembly, for instance. If I double click on that assembly, okay, it brings me into the SolidWorks Explorer area for that specific file, and I can hit references and it will show me all the files that that particular assembly is referencing. And again, it'll let me scroll through those so I can see everything here, right? So if we go to tree ring, for instance, and I select tree ring instead, I have this nifty little where used tab that'll say, hey, that tree ring is actually used in the tree stand. So this is allowing me to look upstream and see, hey, all the assemblies that may reference this tree stand. Now again, this is going to come back to the little caveat I have at the end about locations. This is working really well because I've got all my files in the same folder. If you don't have all your files in the same folder, you have to actually add folder locations, very similar to how we do in SolidWorks, and I'll talk about that in a second. So if we go back to the PowerPoint presentation for a second, when you right-click on a file in SolidWorks Explorer, you're going to see a couple different options. You can select it in the local tree, which is just the left side versus the right side. You can do a pack and go on the file. And for those of you who don't know what pack and go is, it is this fantastic tool SolidWorks introduced a couple years ago that will read references and package up a group of files, say an assembly and all its part documents, and move them to a different location or copy them to a different location. It really is a big time saver. You can rename the file or you can replace the file. Okay? In our case, the replace and rename actually works because SolidWorks Explorer can read these file locations. If you're in Windows Explorer and you right-click on a file, you're going to get a rename option as well. But if you rename that file, the assembly is not going to be aware of it. If you do it in SolidWorks Explorer, it's much more fluid. So let's take a look at how to use this for a second. Let me bring up SolidWorks Explorer again. And so I've got this file right here. If SolidWorks Explorer would open for me. Not exactly sure. It's flashing at me. Let's close it for a second. Try it again. I apologize for that. Bring this back up. Okay, so I've got SolidWorks Explorer open here, and I'm going to go back to that tree stand example. So if we look at the tree stand and I look at the references, tree ring is something that's referenced by the tree stand. Now, this is a fairly simple example because it's only referenced by one assembly. If we go to the tree ring and click where used, there's only one assembly there, but if there were multiple assemblies, it would show multiple assemblies as well. So all I have to do here if I want to rename this file is click on it, and I can click on it here in the left-hand side, which we call the local view, or I could select it over here in the right-hand side, which is the info view, and I can get essentially the same options. So if I go through a rename, what happens is I get a little screen telling me all the files that reference this tree ring. So it's telling me this is the file that you're going to rename. What do you want to rename it to? Okay, maybe I'll call it steel tree ring. And then it's going to say, all right, well, it's referenced by a number of different files. In our case, it's only one. We want to put a checkbox next to all the files that we want to get the updated reference. You also have to hit the update where used to make sure that that thing includes it as well. As soon as I hit OK to this, not only does it rename the file, so we've got a file right here, it's called steel tree ring now, but if we go in there and we look at the where used information, it's still used in that tree stand assembly. And if we go to the tree stand assembly and we hit references, it is now referencing that new steel tree ring. So we were able to very quickly change the name of the SolidWorks file, and we don't have to worry now what's going to happen when I open the assembly, because when I open the assembly, it's going to be referencing that new part. And just to make sure that this works, so you guys don't think I'm pulling the wool over your eyes or anything, I'm going to open this tree stand in SolidWorks, and then I'm going to go look at the references and make sure it's pulling these from the right location. Make sure that SolidWorks is actually going to start here. Apparently my computer thinks it's the weekend already and wants to go to sleep, so I apologize for that. Okay, so we've got SolidWorks Explorer. We're going to open up that tree stand assembly. Whole wizard error, that's okay. Alright, so there's our nice little tree stand assembly. Going to open that right up. I'm not going to worry about the textures. Okay, we'll throw a little rebuild on there. And what you should see right here, steel tree ring. So I didn't have to do anything. We just renamed it in SolidWorks Explorer. SolidWorks Explorer took care of all the references for me. If we look at those references, we can see exactly where all the different files are coming from. It's very important. I should also mention, and I don't have this in the PowerPoint presentation, this Find References box is very helpful when you're dealing with SolidWorks files. If you have issues with references, you can get this from the File menu, Find References. And what I'll suggest for people to do is to use this every time they open a file and every time they save a file. So when you open a file, go to Find References, make sure it's looking at the right stuff. And before you save a file, go to File, Find References, make sure it's looking at the right stuff. That way you're not saving files that have bad references in them to begin with. Okay, so the other thing that we want to talk about here is moving files. So the problem with moving files is that it's a lot trickier. There's no right-click move file like there is a right-click rename file. So we have to do this a little bit differently. And we can do it using SolidWorks, or we can do it using SolidWorks Explorer. I happen to think using SolidWorks Explorer is a little bit better. But basically what I want to do here is, and I'm just going to go through this on screen instead of reading it off from the PowerPoint. apparently SolidWorks Explorer does not like to be minimized, so I'll bring that back up here. Okay, so what we've got is, let's go with another one of these. So on the tree stand, it's using bowl. So what I want to do is I've got bowl here, and if I do just a right-click copy on that, okay, it's going to ask me if I want to do a pack and go copy or a normal copy. I'm just going to do a normal copy because I want to put another copy of it somewhere else. So we'll choose a normal copy, and I'm going to put that copy in this bike pump folder. So I'll just right click on the bike pump folder and paste it. And if you look in our bike pump folder right now, we should have bowl.sldprt. Now the problem with this is I've got two of these right now. So I've got it in this folder and I've got it in the original folder. So up here in the original folder, what I need to do is right click on it, and I can choose the option to replace the file. So I'm going to replace this with another file. So I click replace. It brings up the exact same window we saw during the rename command. It says, okay, this original bowl solid part is used in that tree stand assembly. What do you want to replace it with? So I'm going to hit my browse button, and I can browse into that folder. So we're going to go into the bike pump folder where it's got bowl.sldprt. We'll hit open. That looks like it's coming from the right place. I'm going to hit OK. It's going to go through and rewrite that reference. And so if I look at this bowl SLDPRT in the number 3 folder and hit where used, it may not have updated quite yet. And this actually may be a reference issue that I have problems with. And that'll be a good point for later. Let's go to this tree stand assembly and look at its references. Okay, so it's still pulling everything from there. So we didn't quite do that right. And that's actually a good lead in to this. So if you go into the options of SolidWorks Explorer, what you're going to see is that it's got a references where used tab. Now really right here, I don't have anything inside these folder paths. And if I don't have anything inside these folder paths, SolidWorks Explorer is really only going to look in the folder that the files exist in. So if I come through here and I actually add some folders, okay, so I'm going to add the tree stand folder, and then we'll go through and add all these, the ball pump, and I'm going to add the bike pump folder. This is going to expand SolidWorks Explorer's capability to pick up different references and relationships. Okay, and what that means is essentially, like I said before, this isn't a magic button. Okay, so unless you have it set up properly, which I didn't, and you're using it properly, which I wasn't, it's not going to do what you want it to do. So we'll try this one more time. Now that we got those reference files up there, and we'll see if we can get some information. Now it works. So if I select bowl in the 3 folder, now we see that it goes to the tree stand assembly. And if I select the tree stand assembly in the number 1 folder and do references, it's pulling bowl. It's interesting that it's still pulling bowl from that wrong folder. I'll have to look into that, but really we've still created that where used information, and that other information should have updated as well. So just something to be aware of when using SolidWorks Explorer. Much better at renaming files than moving files, but it still is even easier than moving files inside SolidWorks. And moving files really is the most difficult thing because there's no way really to remap it in the first place. So let's go back to this PowerPoint. Okay. Just my next slide here is warning you guys about the file locations. So if you don't have those file locations mapped, you're not necessarily going to get all of that reference and all that where used information that you're expecting. So let's keep that in mind if you're going to use SolidWorks Explorer. That goes for the rename as well. If I was to rename that file and it was using files outside of the folder it was in, unless you have those locations mapped, it's not going to go through and it's not going to find those references. Okay, so other methods of doing this aside from a data management tool, and I'm going to tell you guys at the end how a data management tool makes this a lot easier, but assuming we don't have a data management tool, you can do this in two other ways. The first way is to use Windows Explorer. So you can go into Windows Explorer, you can right click on a file, rename it, or you can click on a file and drag it into another folder. If you're going to do it that way, you then must open the assembly in SolidWorks. It's going to tell you that it can't find the reference, and you're going to have to browse for it. Once you browse for the reference and save the assembly will be updated with the new name or the new location, and you can go on your merry way. The problem with this method is that you have to know every single assembly that needs to be updated. So if that's a common component that's used in 10 assemblies, you have to do this one by one to every single assembly. The other option is to use the Save As command in SolidWorks. So if you've got a part like a bracket, and that bracket is used in multiple assemblies, what you can do is you can open all the assemblies in SolidWorks, and then you can open the bracket. And if you do a file Save As on the bracket, and during this process you could either give it a new name or a new location or both, once you hit that save of that Save As command, it will update the references of every single assembly that's open. So it'll take care of all of that for you. Now, there's two problems that you have here. If you're moving this, you've still got 2 copies of that file, so you have to go back and delete the original. The other thing is, it's only going to update the references if you have the file open. So if the assembly file or the drawing file isn't open when you do this, it is not going to update the references. The third thing I should mention that's not written here is that if you use a Save As copy, this will not work either. The difference between a regular Save As and a Save As copy is that a Save As will update references, a Save As copy will not update references. So make sure you don't have that option checked if you intend on updating references. Okay, so moving on, let's talk a little bit about revision control. Now, without a data management tool, revision control is incredibly difficult. And this is basically the whole reason data management tools were created in the first place. But you have a couple methods that you can use to do this. And like I said in the beginning, I've seen people do this a ton of different ways. Some ways work, some ways don't. So make sure you use your discretion when you're trying to choose a way to do this. But here's what I've seen. If you are not required to maintain history of the files, meaning you don't have to be able to go back and grab a Rev A if you're at a Rev D right now, you can simply use a property inside SolidWorks to do this. So you go into SolidWorks, you create a custom property that says revision, and you track the revision that way. Okay, very easy to do inside SolidWorks. I'm sure everybody knows how to set up a custom property. If you do need to maintain history, things get a little bit more difficult. And you've actually got a couple methods of doing this if you need to retain history. The easiest way is to revision control the deliverables. And what I mean by that is most people have a deliverable drawing that they use on their shop floor. Most people keep this in the form of a PDF. So if you've got a bunch of drawings of your assemblies and you release them and you create PDFs of all those drawings, you can rev control those PDFs simply by putting the revision in the file name. And because PDFs don't have relationships to each other, if you're doing that, you don't have to worry about messing up any file relationships in the process. Okay, the downfall of this is that if you're only rev controlling the PDFs, well, what happens when you have to model an older file? Well, you're going to have to pull that PDF and you're going to have to use that drawing and you're going to have to remodel it. So you may lose some time there. That's the downfall, but it is very easy and you don't have to worry about file references. The other option is that you have to rev control everything. You have to be able to go back to older files. You need to have history behind everything, and that is where this gets absolutely the most difficult. So the question I put out there is, what if you have a 10-part assembly that's at Rev C, 3 of its parts are at Rev A, 3 of its parts are at Rev B, and 4 of its parts are at Rev C? Okay? What do you do if one of the Rev A parts bumps to Rev B? Does that affect the assembly? Does it not? Do you need a new rev on the assembly? Do you not? How do you manage which rev the assembly is pulling from? How do you get the older versions of the assemblies? Okay, how do we control these situations? And how do we enforce that when we go back later and look at this, that it's accurate and we didn't mess something up? So the way I've seen this that works the best outside of using a data management tool is to take your assemblies at their released condition, put them in a folder, and zip that folder up. What's typically done is that people will make a folder called Rev A, call it part 1, 2, 3 Rev A, whatever you want to call the folder. They're going to put the assembly and every single file that the assembly needs in there, all the drawings, everything, and they're going to zip that folder up. Once you zip that folder up, you've taken a snapshot in time of what that part file was. As you go on and you pull everything back out of that folder and you make your changes, you get to Rev B, you do the same thing. You dump it in a Rev B folder, zip it up. Those zip files become your stable files so that if you need to go back, you know exactly what it is. The problem with this is that that takes a lot of management and it takes a lot of diligence from the users to make sure that they're following through on this process. It also requires you to check before you do this zip that you're zipping the right stuff, because it's very easy that you could be referencing an old version of something and not necessarily notice it and zip it together, and when you get it a year later it's wrong and nobody can tell why. Okay? Some people will put revisions at the end of the file names, of the SolidWorks file names. That is something that can help with clarity. The only reason that I don't recommend that is because data management tools do not like that. If you have any plans to move to a data management tool in the future, be it within a year, be it within 5 years, if you're thinking about it, I really encourage you not to add revisions to the file names, because when you migrate to your data management tool, if you want to migrate all that historical information, it's going to make the process much more difficult, because you have to go through and you have to strip out all those revisions from the file names. That's just the way data management tools work. They manage revisions differently. They need to have the same file name all the time. They don't want revisions at the end of it. Okay. Just last but not least here, we're going to talk about collaboration a little bit, and I'll show you some clicks inside an actual data management tool. But you know, it's really common if you have more than one engineer working on stuff that you'll be saving files on a server. Okay, that's what I'm referring to as collaboration. Multiple people using the same set of files off like a shared drive somewhere. You get a couple of things that people complain about when they're doing this. The number one thing is going to be file overwriting. You know, I made a change to this file yesterday and I opened it today and it's different. What happened? Okay. You're also going to get slow opening and saving performance in certain cases, you know, depending on a couple of factors. You could be pulling up outdated information that you store locally. I mean, you guys saw the SolidWorks referencing algorithm, right? You open an assembly off of the server, but you've got a couple of old parts on your local machine. There's definite potential it's going to find and load those old parts, and that assembly is not going to be correct. And you can also have references pointing to other people's computers if they're saving locally to some unique drive that they have, and it's looking for that drive when someone else goes to open it. So those are probably your 4 biggest problems that people complain about. If you're looking at this, you know, one of the first things that you should do if you're working in a collaborative environment is to go through and turn on the collaboration settings inside SolidWorks. So if you go in SolidWorks and you go Tools Options, you're going to see down at the bottom, and I've got it highlighted in the screenshot here, Collaboration. So you can turn on this checkbox that says Enable the Multi-User Environment, and what this will actually let you do is if you're opening files off a server, if you've got some of those files open read-only because someone else was working on them, it will ping you when those files have been changed so that you can reload the changed versions of the file. You don't necessarily have to get on the phone and call someone and tell them when you made a change to those files. The other thing it will do is it'll add menu items into like your shortcuts to allow you to change whether you have read-write access to a file. So if you took write access to a file by accident, it'll add a little button there that'll allow you to reload that document read-only so that someone else can make a change to it. Okay, so just one little thing that you should turn on, and if you want more information on that, you can go into the SolidWorks help file and pull that information out. So the next thing is that, you know, even if you have those multi-user settings turned on, it's by no means going to enforce any sort of rules. Okay, so you have to understand that people are the link here. You cannot rely on the software to do this for them because you don't have a software in place that will do that. So you have to have procedures in place at your company that will allow the users to follow that procedure. It's going to make you significantly more effective. Now, when we're talking about slow opening and slow saving, you know, this is because you're working across a server. Okay, and this is just inherent with storing files on a server. The longer the distance is that you have to go to get something, the longer it's going to take to get that thing. So when you open a file or when you save a file that's not local to your computer, it's definitely going to take longer. There's nothing you can do with that. Now, the question I get asked a lot is, does that mean the solution is to work locally? Should we be playing with these files locally? And in some cases, this can be a really big benefit. However, again, without a data management tool in place, a lot of things can go wrong with that you need to be aware of. So the first thing is that when you save a file that has references, you know, the location of those references are saved in the file header. So if you're saving files locally that are referring to local folders on your computer, and then you copy them back to the server, the next person that opens that file, it's going to be looking for references on your computer. That's just the way it works. Okay? If you have files locally, you also have indefinite write access. So if I take an assembly and all 100 of its components and I copy them locally so I can open it up, I have write access to all those files, which means I can be changing stuff that I don't really need to be changing. So you have to be diligent about managing that, or you're going to end up with people making multiple changes to the same file, and then whoever ends up copying it back to the server last wins, basically, right? The other thing that can happen is copying files back to the server. So if you're going to work locally, you're going to copy them locally, then you're going to work on them, then you're going to copy them back to the server. And that could take time. If you have huge assemblies and that you have to copy everything locally to have reference files and all that kind of stuff, this could make you much slower than if you were just working off the server in the first place. So you'll have to balance that. And the other thing, again, is outdated information. If you're moving a lot of data between your computer and the server all the time, you really, really have to be smart about controlling what's on your local machine. Because like I said, if you have an old outdated version of some file and you open the assembly, there's a huge possibility that it could find that file and, you know, it's opening the assembly with the wrong information. So what can be done to help in these situations if you do want to work locally? Well, kind of like I mentioned before, is that I suggest everyone having a common folder. So if you have a folder at the root of the C drive, and in my example here I call it C working, you can call it whatever you want, but if everybody has that folder and are saving to that folder and are saving files in that folder, then no matter what computer you go to, it's going to be looking for the C working drive. So it's not going to be looking for Bob's desktop test folder. Okay, so it just makes it a lot more consistent for people to work with. The other thing is that you need to know which files you should be changing, and don't mess with files that someone else is responsible for. Okay, this comes down to just the human element of this. We have to be responsible as we're designing, and we have to make sure that we're not inadvertently changing something that we shouldn't be changing. It happens all the time. People will go out and they'll build prototypes to the wrong rev and they'll raise $30,000. I see it constantly. So we have to be a coherent group of engineers. We have to make sure that we're only changing things that we should be changing. The other thing you want to do is keep your local cache clean. And by local cache, I mean the files that are on your local computer. If you're pulling and pushing and pulling and pushing, you want to make sure that you're cleaning that cache up so that you're not maintaining outdated information that's going to cause issues down the road. Okay, file overwriting is another big thing. And unfortunately, there's nothing we can do for this. Okay, if you make a change to a file and save it, but somebody else had an old version of the file, they make a different change to it, they save it over your version, there's really nothing that can be done there when you're storing files on a server, because the server only has the one copy of it. Their changes end up trumping your changes, and you go to open it a week later, and there's nothing you can do other than maybe restoring a backup if there was one in between that time period. And so this all comes down to communication, right? Communication and responsibility as designers. If you don't have a data management tool in place that can control these types of interactions, you need to be communicating with your design team. You need to have meetings. You need to make sure that everybody knows what is expected of them so that you don't run into these different types of issues. Okay, and so kind of the last thing that I'm going to do here is I'm going to click through a couple things inside a data management tool just so that you can see the difference that it makes. There's a lot of data management tools out there. Obviously, we've got our recommendations. I'm going to try to keep this somewhat generic though, but they can take away a lot of the pain from these manual processes. You know, and a data management tool adds a lot more than file control and rev control. You can do lifecycle control, you can automate common tasks, you can help collaboration across multiple sites. I'm not going to focus on any of that stuff today. I'm really just going to talk about where it can help the issues we've already spoken of. Okay, and so if we go look at this, the first thing I have written there is get a database. Okay, lots of data management tools out there. They don't all have databases, but the ones that are really worth their salt do. They'll have a SQL database or an Oracle database behind them. What that database does is it gives them extensive mapping capabilities far beyond standard Windows mapping capabilities. And what that means is that files stored in your data management system are going to know where their references exist without having to worry about breaking references all the time. It really is significantly more elegant than storing files in Windows. Okay, and so where does this help? So we talked about SolidWorks references. So how does a data management tool help this process? Well, the first thing that you should know is that the SolidWorks algorithm for finding references does not change when you have a data management tool in place. Okay, so if it doesn't change, how is it helping it? Well, where you're getting benefit is that you're storing all your data in a common location. Okay, everybody is working off of the data management tool, which means that everybody is pulling from the same set of files. So if you go into SolidWorks and you set your SolidWorks file location options to that location, then you're going to find these files a lot quicker because it's happening earlier in the algorithm rather than later. Okay, the next thing is file renaming. And file renaming is where you see a huge difference as well as file moving. And so I'm going to explain this and then I'm going to show it really quickly. So when you have a database controlling your files, what happens is that the file name becomes a secondary piece of information. So when you take a file and you check it into a data management system, the data management system assigns a number to it. And that number is what the data management system refers to for the rest of the time the file is in the tool. So if you rename it or if you move it, it doesn't matter because that identification number doesn't change. And that is what SolidWorks and the data management tool use to create the references. So whether you're renaming a file or moving a file, this thing all works the same way. So here's what I'm going to do. I'm going to take some of those example files that I had on my desktop. Okay, so we had this little ball pump folder, and I'm just going to copy that, and I'm going to drop it into my data management tool. And by the way, I'm using a system called Enterprise PDM. This is kind of our recommended data management tool, but this should work the same way with basically any data management tool. So what I'm going to do is I'm going to drop that folder of components in here. Okay, so we'll just do a paste. And then I'm going to perform a operation called a check-in, and I'll talk about this check-in operation a little bit towards the end because it's really part of the collaboration side of things. Okay, 2017, I put that in there, right? So here's our ball pump folder. I just want to check those files in. When you do the check-in, this is where it's building the list of references. So you can see the tree that comes up. It's saying, okay, here's everything and here's all the relationships that exist. And this is where it's building that intelligent, document ID system. So we check all that stuff in. And now if I go in here to this ball pump and we go to something like the ball pump assembly, I can click on the bill of materials and I can see that all those references are there. I can also click on the Contains tab and I can see it in sort of like a tree structure. Okay, but here's the whole point to this thing. Let's go something with this rod, okay? Rod is used in the handle subassembly, and the handle subassembly is used in the ball pump subassembly. So what happens if I go and I change the rod? Okay, and this is all just Windows Explorer. So I'm going to right-click on that rod, and I'm just going to rename it. Okay, so oops, I didn't mean to cut it. I just want to rename it, and we'll name it something different. New rod. New rod. Okay, as soon as I do that, the data management tool has updated everything. So if I click on it and I click the Where Used tab, okay, and we go through here, we can see that it's still used in the handle, and it's still used in the ball pump assembly, still used in the ball pump drawing. If I go to the ball pump assembly, click on our Contains tab, well, here it is. It's in the handle assembly, which is still in the top assembly. So I didn't have to do anything. It's just a right-click rename. The data management system takes care of everything for me. Very similar to what SolidWorks Explorer would do for us. However, this is now global. I don't have to worry about file locations or anything like that, because this works for anything contained inside the vault. So I don't have to go and I don't have to put all those reference file locations in. The other thing is that moving files is significantly easier. So I'm going to grab something else. We've got fill pin, and that's just up there in the top level assembly. So I'm going to grab that and I'm going to cut this one. Okay, and I'm going to go paste this into a completely different folder. Let me paste it into the marketing folder for example's sake. Okay, so paste that in the marketing folder. I moved it. It's gone. It's not in that engineering folder anymore. So if we go back to that ball pump folder and I find that ball pump assembly and we look at the Contains tab, okay, fill pin is still there. And if we scroll over and look at the actual file location, we can see that fill pin is shown as being in the marketing folder. So I didn't have to do anything here. All I did was drag it and drop it into another folder, completely remapped and re-updated. And that is the real true advantage of having a database in the background managing this kind of stuff for you. Makes those operations significantly easier. Okay, in terms of revision control, like I kind of said earlier, this is really the reason that data management systems have come into existence. So what it does is it controls the different copies of these files in the background. So as you make a change to a file and you put that new version of the file into the system, the data management tool is going to keep a copy of that, and it's going to write all the attributes to it so that it knows exactly where it fits inside of time. Okay, so this is where you've got your assembly at Rev A and your assembly at Rev B. And Rev A references different components than Rev B does. So if you go and open Rev A, it'll open Rev A with the right components. If you open Rev B, it'll open Rev B with the right components. You don't have to do any of that appending rev names to things. You don't have to do file zipping. You don't have to do any of that stuff. It is all there inside the data management system. What this also allows you to do is track the history of the file. So when someone checks a new file in, you know who did it, you know why they did it, and its date timestamp. It will also allow you to roll back. So you started making changes and you went down a completely wrong path. Well, you can go back to where you started and just get rid of those changes you made. So just to show you that a little tiny bit here, inside this I've got a file that actually has quite a few versions on it. Right, so if I go in, this is just a Word document. You know, something cool about a data management tool is that it doesn't just have to be for SolidWorks. But this particular file has a lot of different versions and a lot of different revisions. So I could go through and I could open up any of these that I felt necessary to see. So if I want to go and see what an assembly looked like 5 years ago because we got a warranty call for it and it's changed since then, I can pull that up instantly because the data management tool is covering me in the background. And if I want to go look at the history, this is just again for a single document, but I can see here who has made changes to this file. I can also see comments that they've left when they made those changes. So I know what was done. We removed some fields, we sent it up for review, we unbolded some stuff. That's exactly the kind of thing that you want, and all of this is happening automatically inside the system. So it's just really another advantage of having that data management tool in the background. And kind of the last thing I'm going to mention here is, collaboration. How does this make collaboration better? All right, so one of the fundamental reasons that these data management tools are around is to help you control access to files. Okay, so a couple advantages you're going to get here. The first is that it's going to manage the movement of files between the server and a local drive. So when you're working on a file, you want to work on it locally because that's where you're going to get the absolute best performance benefit. So what the data management tool will do is when you go to work on a file, it'll bring that file to your local drive, you'll work on it, and it will push it back up to the server when you're done. That way you don't have to manage that process and you don't have to worry about any sort of references being out of whack. What the data management tool also has is this concept of checkout. And basically what that means is that when a user checks a file out, they are taking responsibility for that file. So when I have a file checked out, nobody else can have write access to that file. So until I check that file in, nobody else can make changes. Sure, I could check the file in and somebody else could grab it and make changes, but the great thing about that is I've got two versions now. So if their changes were unacceptable, we can roll back to my changes and ditch what they did. I can also go through the history and I can look and I can say, hey Joe, why'd you make a change to this? You weren't supposed to do that. So everybody's much more accountable now that you have this concept of checkout. It gets rid of a lot of those overriding issues, a lot of those pulling the wrong reference issues that people run into. Okay, and so that's just kind of what I wanted to talk about on the data management side of things. A data management tool can do a ton of stuff. It can control life cycles, it can really it can do ECOs, it can do all sorts of other things. It's got a lot more functions. If you guys want, on our website at hawkridgesys.com, under events and recorded webinars, there's a recorded webinar much like this called Enterprise PDM Overview. It goes through a lot more of the SolidWorks data management stuff and capabilities that it has if you wanted to watch it. Other than that, I just want to point out a couple other things here. So here's our summary, right? These are my 3 main points. Number 1, understand how the SolidWorks reference algorithm works and play within its boundaries. You can definitely use that to your advantage, okay? Second point is to be extremely careful when moving and renaming files because that is the biggest source of reference errors that we see. Okay. Third thing, communication's key. You absolutely want to make sure that you're communicating with your design team. If you guys have any questions about this, I've got my contact information up there. Please give me a call, shoot me an email. We can talk about anything a little bit more in depth. I am going to have the recorded version of this up in about a week. So check our website and you'll be able to get the webinar as well as this PowerPoint if you want to share it with anybody else. And I'll hang around for a while and answer some questions, but if you don't have any questions and you want to leave, thanks very much for coming. I appreciate you taking the time out.